This magnetic oil gauge, which we can see is mounted onto the side of a tank, is used to measure the liquid level within the tank. If we zoom out, this is actually a conservator type tank fitted to an electrical transformer. You'll see it's long and cylindrical in shape, and the magnetic oil gauge is mounted onto the end. The magnetic oil gauge has a float. I'll just go inside so we can have a look. And the float is attached to a float arm. So there is the float, and there is the float arm, and this will actually connect to a dial gauge, which is this one here. And as the float moves up and down, it's actually going to give us a level indication on the outside here. The red lines at the bottom of the gauge, these signify alarm set points or perhaps trip points, and these will be relayed back to a control room or a manned area. You can see also the junction box where we connect our cables and another cable connection here. We can see that there is a min and a max indication, and we can also see what the level should be at approximately 20 degrees Celsius. So let's see the gauge in action. Okay, so imagine the liquid level is increasing until it reaches max. And as you saw there, the float has now moved up to the top of the tank. You can see that the float is synchronized with the dial gauge, so that the position of the float is directly proportional to the level that it indicates. And now we can see the float coming back down again, and that is how our magnetic oil gauge on a transformer works. The gauge itself is actually coupled from the inside to the outside via a magnet. The magnet itself is what they would term a driver and a follower. The driver magnet will pivot along with the float, and as it pivots it will also rotate the follower magnet, and the follower magnet will be connected on a rod to this needle on the dial gauge, and that will make the needle turn and give us a reading on the dial gauge. A relatively simple piece of instrumentation. Sometimes you'll see these magnetic oil gauges, or MOGs as they're called, with a bevel gear. This is just an additional component in the drivetrain between the float and the needle. But the essential concept is that as the float moves, a proportional response should be given on the dial gauge, and this should indicate its level. So let's have a look now using a 2D animation. We can see here as the level in the tank increases, the float will be carried up, and as the level decreases, the float will be carried down, and the indication will change in proportion to where the float is. There are other types of magnetic oil gauge. This is a different type. As we can see, the tank level is increasing and decreasing, and what we'll have is a float, which is a magnetic float, and as this travels up through the channel here, the magnet will rotate a red dial, and if it indicates red, then that will indicate where the level is. As it travels back down again, it will flip these red dials back to the black position, and that will then indicate that the magnet has travelled downwards, or the level has decreased. So this is a different type of magnetic oil gauge. The most important thing to realise with magnetic oil gauges is that they are very useful when you are taking a direct measurement but you do not wish to mix two systems. For example, the MOG, as it is here, is completely contained within the system, and the gauge, which is mounted on the outside, does not come into contact with the liquid contained within the system. We can also see this on our other example. As we can see here, the gauge is not connected to the interior. It is actually coupled via a magnet to the interior, and this means that the interior and exterior are completely separate. This reduces the risk of leakage through things such as gaskets or O-rings, which we may require for sealing. It also makes maintenance of the exterior components a lot easier.